Hello, welcome to Mathematics with D, and today we're going to be doing problem 15 from homework 3. This involves trying to, increase our understanding of a concept. Now, in this problem, we are given the value I equals the integral of f of x dx over f of x plus f of a minus x bounded from 0 to a, and we were asked to make a substitution of u equals a minus x and then add it back to the original I. So let's just jump right into it. So we made the substitution u equals a minus x, and then we derived that to get rid of the dx, and we got du equals minus dx. So, and when we put the bounds into our u substitution, the new bounds are a to 0, so the integral ends up being negative f of a minus u du over f of a minus u plus f of u, and that's bounded from a to 0. But we know that to reverse the sign of an integral, we just flip the bounds. So to make this positive, we flip the bounds a to 0 to 0 to a, and we have f of a minus u du over f of a minus u plus f of u. Now we add it back to our original I, so we have I equals the integral from 0 to a of f of x dx over f of x plus f of a minus x plus the integral of 0 to a of f of a minus u over f of a minus u plus f of u. And at this point, the variables don't matter when it comes to x and u, so we have the integral of 0 to a f of x dx over f of x plus f of a minus x plus the integral of 0 to a f of a minus x dx over f of a minus x plus f of x. And if you were to cross multiply to get the same denominator, well, the denominator is the same. We can just add the top values. We can add the numerators together to get the integral of 0 to a is f of x plus f of x minus a over f of a minus x plus f of x, which is actually equal to 2 times our original integral. And we have 0 to a is actually, when you cancel all this out, it's just equal to 1, aka dx. So we have 2I is equal to dx integrated on the bounds of 0 to a, which is equal to a. If you have dx, it becomes x, because technically 1 is x to the 0th power, or the variable to the 0th power. And what you do is you add 1 to the exponent of the variable and then divide it by n plus 1. So we have 1 to the 0 x to the 0 plus 1, so x to the first power divided by 0 plus 1, which is 1, so we just left with x. And we substitute our bounds in, so we'd have x to the, a minus 0, and we're left with just a, and all that's equal to 2I, so I in this case is equal to a over 2. Thanks, and that's how you solve the problem.